Hello, and welcome to Lecture 6, where we're going to do our first real macro model. So remember that last week what we did is we looked at microeconomics. So we looked at both the microeconomic theory of the firm and the microeconomic theory of the consumer. And now what we're going to do is we're going to take those two pieces and we're going to put them together to make our first simple macroeconomic model. And as you can see from the title here, this has two components to it. So this model is going to be a closed economy, which means that there will be no trade or no interaction with the rest of the world. It's as if we have an economy that, is completely closed off, is in autarky. And the other component is that it will be a one-period model. And now we talked about this already. What this means is the model is static, or everything happens in one period. So what this really means for us is that the consumer doesn't have to worry about savings. There are no savings. And likewise, we're restricting the firm to have a set amount of capital. So the firm cannot pick its capital stock. It's just given. And so with that, let's begin. So just to recap, recall that what we're doing right now is we're building this new classical theory of the economy. So in about the 1980s, these new classical economists came around and they said, we need to have these macroeconomic models that start from micro foundations. So where all decisions by firms and by consumers are based on microeconomic optimization. And so that's why last week we looked at both the theory of the consumer and the theory of the firm from this microeconomic angle. And so just to recap here, what does the theory of the consumer tell us? So the consumer, in this theory, looks at prices in the economy. So that's W in this case, the wage, and also some allocation, so its profits and taxes that it receives. And given those, it chooses its labor supply, or leisure, which amounts to the same thing, and also its consumption, so as to maximize utility. And then what about the firm? Well, the firm also looks at prices in the market. So it also looks at W, the wage. It takes this as given, and then given that wage, it chooses labor demand to maximize its profits. So in both cases, we have the firm and the consumer looking at prices in the market, and given those prices, choosing what it wants to either supply or demand in the marketplace. And so really, if you think about it, what this says is, for the theory of the consumer looks at wage, and then given the wage decides, for example, how much labor to supply, which gives us a labor supply curve. The firm, meanwhile, also looks at wage, so that's our price in the economy, and given that wage, chooses its labor demand. And so now what are we going to do? We're going to say, given those two pieces of the puzzle, the theory of the consumer and the theory of the firm, we need them to interact somehow. And the way we're going to do that is they're going to interact through competitive equilibrium. What that means is we're going to say that, well, then the wage must be such that the amount of labor that the consumer wants to sell or supply must be equal to the amount of labor that the firm wants to demand. And so you can imagine that really what we're doing, and you've seen this no doubt in first year, is we're going to say the wage must be the one that leads to the intersection of these two curves. And that's really all we're going to be doing in this model. And so that's what I write here. So we must have W, the wage, and profits such that the labor market clears, meaning that labor supply is equal to labor's demand. And also the goods market clears, which means that everything which is purchased in the economy, so that's both consumption and government expenditure, has to be equal to everything that's produced, and that's given by our production function. So we're taking these two pieces, the theory of the consumer and the theory of the firm, and now we're just saying prices must be such that these markets clear. And we're also adding one thing that we haven't seen, which is going to be the government. And to be honest, what we're doing is we're adding a pretty boring government. So the government is just going to spend amount G. It's going to raise taxes T in the same way we've seen already. So these lump sum taxes taken from the consumer. And it's going to balance its budget. So it's just going to set G, its expenditure, equal to T, its tax revenue. And so why are we introducing this government? Well, it's really just going to allow us to see what this model says about the effects of government expenditure. And so you'll notice that the third part of this lecture is going to be all about that. And so I'll have much more to say about this shortly. Okay, so we have to introduce a few more concepts here before we do anything else. And the first one is the production possibilities frontier. And so maybe some of you have seen this already, but for those who haven't, I'll say that the production possibilities frontier is really what it sounds like. It's the possible production quantities the economy can create. Or what I wrote here said, given the economy's technology, this shows the possible bundles of goods that can be produced. And so the classic example, I think, comes from Paul Samuelson's textbook in the post-war era. So this is after World War II, during the Cold War. And so I imagine because it was the Cold War, the two goods that he focused on were guns and butter. And so what this production possibilities frontier says is, for a given number of guns that I can produce, how much butter can I also produce? So for example, if I choose to produce this many guns, that means that I can produce this much butter. Okay, so if I'm using some amount of the economy's total productive resources for guns, then what's remained, or that is those productive resources that remain, I use to produce butter, allow me to produce this much. But if I take some of those productive resources away from guns, so I move this way, and I produce this smaller amount of guns instead, well, then I shift some of those production resources, or productive resources, towards producing butter, which of course allows me to produce more butter. And so really, all this says is any point on this curve are possible bundles of guns and butter that I can produce when I'm using all of the economy's productive resources. Now, one important concept from this is, I left myself a note here, MRT, which is the marginal rate of transformation. And what this is this says how many or how much butter can I get by sacrificing production of one gun in this case. Or, seeing it graphically, it's really just the slope of this production possibilities frontier. So for example, at this point right here, it's not quite tangent, but you can imagine that line there as tangent. The slope is equal to the marginal rate of transformation of guns for butter. Meaning that at that point, when I give up one gun, how much additional butter can I get? So it's this idea that I'm transforming guns into butter. I mean, not directly, but effectively that's what it is, right? I'm taking away productive resources from guns and using them instead for butter. And the slope of the line here is giving us the rate at which I can do that. Now, in our case, of course, we're not interested in guns and butter. I mean, it's not the Cold War anymore. And so in our case, right, in our model, we have two goods, which are consumption and leisure. But we want to do the same thing. We want to create this production possibilities frontier. And I'll show you that given the tools we have, we can do it pretty easily. It takes about 3 steps. So step 1 is just to look at the production function. Okay, so let's just remember what the production function is. Sorry, the production function takes labor and tells us, given that much labor, how much output Y do we produce, right? And it's given by this equation we had before, which defines the production function. Okay, that's all well and good. Now, the next thing we want to do is to flip this production function. So what do I mean by that? I mean that really we could reverse the axis and instead express it in terms of leisure, okay? Because remember that leisure is just the total number of hours available minus the amount of labor supplied. And so given that, we can kind of we can reverse this production function. So instead of having n on the x-axis, let's instead put leisure. And so that means that 0n, so zero amount of labor supplied, is equivalent to leisure equal to h. And then as I increase labor supplied, that's the equivalent of decreasing leisure. And so you'll notice that we can express this production function in this way, in terms of leisure and instead of labor. And so now you'll notice we're already getting there. We have this curve that looks very similar to what we had on the last slide. The only difference is what we want is this to be in terms of consumption and leisure. Right now we have leisure and output. So what we want is a curve representing consumption and leisure, not output and leisure. Now, luckily, this is pretty easy because notice that we have the following relationship, which is that total output, Y, is equal to consumption plus government expenditure. Or rearranging this, consumption is just equal to Y minus G. So what does that mean? It means that if we were to take our reversed production function that we saw in the last slide and just shift every point on it down by amount G, that will give us C. And so therefore shifting every point down on that on that reversed production function will give us our production possibilities frontier between consumption and leisure. So what's that going to look like? Well, now since we're shifting everything down, we're going to have that it starts at point G, okay, or negative G, negative G. Or in other words, what's consumption when leisure is equal to H? It will be negative G, right? Because if leisure is equal to H, that means Y is equal to 0, and so therefore consumption is equal to negative G. Okay, so we've shifted everything down, so now it's going to look something like this. And this now gives us our production possibilities frontier, which gives us a relationship between the amount of consumption we can possibly have and the amount of leisure we can possibly have, given the amount of government expenditure there is in the economy and given our technology for production. Now, the one other thing we might ask then is what's the marginal rate of transformation of our PPF, of our production possibilities frontier? And remember that the marginal rate of transformation is given by the slope at any point. Okay? It's telling us how much additional consumption can I get if I sacrifice 1 unit of leisure? Right? Okay. Well, given that this is just a flipped production function that we've translated down, the slope is just the same as the slope of the production function. In this case, the slope will be negative. So it's just negative the slope of the production function, which is the negative of the marginal product of labor. And notice that this makes a lot of sense, right? This is saying, if I give up 1 unit of leisure, so I move this way, how much additional consumption can I get? Well, the amount of additional consumption I can get is the amount of additional output I create by sacrificing 1 unit of leisure. Or put another way, it's the amount of additional output I get by working 1 more hour. And what's that? It's just the marginal product of labor. And so what are we left with? We have that the marginal rate of transformation is just equal to the marginal product of labor. So now, what's nice about this, that now we have this production possibilities frontier, is that it's now in the same space that we were working in for the theory of the consumer. So remember that the theory of the consumer, we were working in this LC space, or this leisure consumption space. Okay? And so what's nice is now we can translate a lot of the stuff we did for the theory of the consumer onto this same graph. And so let's do that right now, where this point is H. So to do that, I'm first going to construct a budget constraint. Okay, so remember, what's the budget constraint? Is it says how much the consumer can consume when it sees a certain wage in the market. Okay, and a certain amount of profits. So imagine now that the firm thinks that, or demands a certain amount of labor, thinks that it's going to employ this much labor, okay, which we call ND0. So this is now the leisure associated with ND0. If it thinks that, that means that it will pay a wage equal to the marginal product of labor at that point, right? We saw this in the theory of the firm, which is that the wage is just given to the marginal product of labor at any point. So in this case, ND0. So that means that it's offering the wage given by the slope of the production possibilities frontier here. And now looking at that wage, the consumer can construct its budget constraint, right? If it works ND0 as the firm expects it to, then it will get paid the wage equal to that slope, and it will be able to consume this much. But it could also pick any other point along this straight line, right? I mean, that's the nature of this wage, is that the consumer really could choose any point along this line if it so desired. And so notice that this is exactly the budget constraint we saw before. But what's going to be interesting about this is, as I said, the consumer can pick any point on this line given what maximizes its utility. So you could imagine it might pick the following point right here. Now, if it does that, notice that we have a problem, okay? And in particular, that's that we're not in equilibrium. So if the consumer picks that point, that means that it's picking the leisure given by, we'll call this, point labor supply 0. But notice that labor supply is not equal to labor demand, okay? In fact, given this wage, the consumer wants too little leisure relative to what the firm wants. Or put another way, the consumer wants too much labor supply relative to what the firm wants. And so we're out of equilibrium, right? Currently, we don't have that the labor market is clearing. Given the wage that we're seeing right now, we don't have that the firm and the consumer want the same thing. Or sort of put in a picture you might be familiar with from, say, first year micro or first year macro. If we draw this as two, a labor supply and a labor demand curve, we're at a point like this, where the wage is currently too high, and so it's leading labor supply to be greater than labor demand. And what will be the result of this? Well, we all know it. It's that because labor supply is greater than labor demand, it's going to drive the wage down. And it will drive the wage down until we have an equilibrium of labor supply and labor demand. So what does that look like? Well, so I say here the wage will now change until the market clears, until labor supply is equal to labor demand. And so we can draw precisely what that'll look like. So I'm going to put my curves back on here. So here's the production possibilities frontier. That's negative G. And the consumer has its budget constraint, which will look something like this. And here we have C and L on our axes. And finally, remember this vertical distance is pi minus t. Now, for it to be in equilibrium, we need that the firm and the consumer pick the same point. So remember that we saw that if this is the wage, that will be the labor demanded by the firm. So we need, for equilibrium, that the consumer will pick the same point. So that is, we need that the indifference curve is tangent to the budget constraint at that exact same point. And that will give us our point of equilibrium. If we didn't have that, we would have that labor supply is greater than labor demand, or vice versa, and that would lead to a change in the wage until we got to this point where labor supply is equal to labor demand. Now, what does this mean for our conditions for equilibrium? We can see it graphically here. What is equal in this graph? Well, a few things, actually. So you'll notice that we have our conditions from before. So that's that the marginal rate of transformation is equal to the wage, which is the same as the marginal product of labor. But notice also that we have that the marginal rate of substitution is equal to the wage. That comes from the consumer's problem. And so taken together, what does this mean? It means that the marginal rate of transformation is equal to the marginal rate of substitution. Or put another way, the slope of the indifference curve at this optimal point, we'll call it point A, is equal to the slope of the production possibilities frontier, which is the marginal rate of transformation. So those are our conditions for equilibrium in this case.